This conference will now
Okay.
be recorded.
Okay. So Diva, if you remember in the last class, we had started about error and we had learned various type of errors, random errors, constant errors, and then systematic errors. So what we are going to learn today is uh, even in the errors also there are some ways, like there are some method to report the error in the measurement. Okay, so there are some method to report the measurement. Okay, I'll tell you what it is. Um, so what is error? Actually, error is the measured value, the difference between the true value and the measured value. Okay, so that is actually error. Okay, that means if you know the true value, that is minus measured value. Measured value means whatever we do measurement and whatever we get out of measurement. So that is called measured value. See, then you might be thinking, sir, what is true value then? Yes, we'll we'll actually have to get the true value, that also by measurement only. So measured value and true value both we are measuring, but out of uh, these two, see the true value is actually this one, the arithmetic mean. Arithmetic mean of all the measurements can be taken as true value of the measurement. So you might be thinking, what does it mean? So true value is, suppose I am measuring some quantity A, okay, or I'll take small a. I'll take small a. So I'm just measuring a quantity A. Then A means you can just think of length of the uh, length of some object. That is also possible. Suppose I'll just take length then. So suppose I am just measuring length with my meter scale or whatever. So what is true value and what is measured value? So see, in any measurement we do in the experiment, we actually do repetition. Okay, what we do, your teacher might be saying, repeat the experiment for maybe minimum 5 times, for 5 times or 10 times, or maybe more than that. Okay, so if I measure this L 5 times, so I'll get, definitely, if I am really honest, I'll not get the value of this length always the same. I'll get different values. In fact, I should get. So suppose L1 I get sometime, and then I get L2 sometime, I get L3 sometime. Like that, suppose I do some n times measurement, n times. So then I'll get ln. So what is true value and what is measured value? The measured value is actually, see, each and individual measurement. These are called measured value. Suppose L1 is one measured value. Okay, measured value. L3 another measured value. So each, see, during each measurement, whatever value we get, that is called actually measured value. Then what is true value? The true value is, if I take the mean of all the measurement, mean, see, arithmetic mean of all the measurements, that means your true value will be, suppose L is equal to L1 plus L2 plus L3. If I have done n times measurement, I'll get n values of length and divided by n. Okay, so this will give you the true value. Okay, so you will get the true value is this one. I have measured 10 times. Each time whatever I get that are called actually each measurement, the length of the object in each measurement is called measured value. And if I take the arithmetic mean, so this is called mean or average, and it is denoted by bar, or sometime we can write L mean, L mean, or sometime with angular bracket. You will see all sort of notations for average value or mean value. Okay, so this is called average. See, average can be see by bar. This is also average or mean value, average or mean value. Okay, sometime you will be seeing it is written mean also sometime. So then also this same meaning, and if it is denoted by angular bracket like this, then also it is the average or mean value of this quantity. So this mean value is actually called true value. So I hope you understand what is mean value and what is measured value. Now, see, today what we are going to learn is actually the absolute error, relative error, and percentage error. This class is very, very important class, and uh, there will be questions from here in various competitive exam as well as your board exam. Okay, this is very, very important topics, error. So if I know this error, then how to report the error? Report the error means you have measured the quantity, then you have some error that according to our this thing, so it will be like, see, it will be L minus L1. So this is for single measurement. Then I'll get another for another single measurement. So like that I can get n times, like n, this kind of differences, right? So this is the difference between the true value and measured value for each measurement, right? So if I take these values, the positive or the magnitude of this value is called actually absolute error. So what is absolute error? Absolute error is actually the difference, sorry, the magnitude of the difference between the true value. So you look, this is magnitude of the difference between the true value and uh, true value and the individual and the individual and the individual individual measured value. Sorry, measured I have written. Measured value is called the absolute error. There is, I think there is no doubt in this sentence, this definition. The magnitude. So I get this one. I'll just write again. Uh, I'll just clean this portion. So I have got the true value and I have got the individual measurements. Okay, I have got those things. So if I take the difference, see magnitude of the difference between the true value, this one, this is called absolute error. Okay, so this is for single measurement. I can take I can take another one. So suppose this is for measurement 1, absolute error. I can get absolute error for measurement 2. Okay, like that I can get for n such absolute errors. How many? N number of n numbers of absolute errors I'll get. Okay, this is L n. Okay, such n numbers I'll get. Okay, so these are actually absolute errors, magnitude of the difference between the true value and the measured value, each individual measured value. Okay, so this is called absolute error. This is the definition of that which I am writing here. Now I'll see what is called mean absolute error or final absolute error. Mean absolute error. Okay, I think you have got the point when I say mean absolute error. See, I have got mean, see, n such absolute error. If I take the mean of those, I'll get the mean absolute error. I hope it is also fine for you. I don't think you will have some problem here. So you get this as mean absolute error. See, I write this plus this, and see whatever absolute error I get, there will be some n numbers of absolute error. I'll just add all of them up. This is the way to take average. You add them up and then divide with the total number. Okay, total total attempt, I should say. So see, I have taken n attempt, so I'll write like this. Okay, actually this can be written in terms of summation also. See, this is a sigma sign. Okay, I'll just clean some portions. So this can be written as written by summation also. See, if I have n number of this measurement, I can write the mean absolute error as this, where see I can write this is delta I. Okay, I can write this is delta I. Okay, so I goes 1 to n. So this is called summation. This method, so this notation actually called summation. Okay, short notation to write a big lengthy summation in this way. Okay, if you are doing sum like this, so these two are actually meaning the same thing. I can write in a very short notation. This is called summation, and this actually called sigma is a Greek letter. Okay, this sign is called sigma and used for many physical entities. Here it is summation. Summation. It is called summation. Okay, so this actually it has its name is actually sigma. Okay, so this is how summation can be expressed, like average can be expressed. Absolute. So what we have learned? We have learned what is absolute error. Absolute error. So there can be many in individual measurement. So this is the magnitude. So I'm just writing for one. So in fact you can write like this. I means many. So I can write sorry, this L minus Li. Okay, this L average minus Li. So with this I actually express all of them. Okay, so this is absolute error. If I take the mean, so mean absolute error also we have learned. So this, this mean absolute error is called final absolute error also. Mean absolute error or final absolute error. Okay, so what we have got this as um, this this means as I had written delta Li. Okay, like that I can write. All right. So there is no doubt about here. If you have, you can ask me anytime. Okay. Do you understand? Do you understand this notation?
Yes, sir.
Okay, good. If you don't understand, you can tell me. Okay. All right. So this is a mean absolute error. In any measurement, I'm doing some like see measurement or experiment. So when I'll be reporting the final value, see what I was doing. I was measuring the length. So finally, I have to write some value. What is the what is the value of the length after measurement? So you see in the experiment, you have to write some final values. So how to write the final values? Actually, in the final value, you have to always report your uh, error also. Suppose this is the final value you are writing after measurement. You have to write the true value plus or minus mean absolute error, whatever we have got. Mean absolute error. So this is how you have to represent. So you have to write your experimental result in this way. Experimental result in this fashion. Okay. Then your see there will be see some marks in for writing the results. Okay, result and discussion. So if you write in this way, then you will get that marks. Generally 2 marks is allotted for this writing the result itself. We see generally when we correct the copies and all in laboratory, we see whether the result has been written in this fashion or not. Any experimental result has to be written in this fashion. Final result you have to write with the value, whatever value, average value you have got. With that you have to write plus or minus absolute error. So this absolute error, you have to know what is the absolute error in your experiment. So that varies actually. That varies if you are just using a meter scale. So you have millimeters, see 0.1 millimeter you can measure. So this is called um, precision. This is the precision of your measurement. So sometimes the precision itself or the least count, okay, sometimes the least count will be this absolute error. Okay, this error you have to find out in which experiment, what is like in various experiment, what are the sources of error, and you have to know what is the error for or absolute error for that source. Okay, so that's how when you know the error, then you write plus or minus that error along with your true value or whatever average value of the measured value you have got. Average measured value, this one. Okay, this is the true value and this is the absolute error. So I hope you have understood this, but still I'll take one example, simple example, just to make this concept absolute error and how to report an experimental result vividly. Okay, so just I want to uh, take one example. Let us take one example. Suppose the same experiment. Suppose I have to measure a length of a rod. Length of a rod is measured. Okay. length of a rod is measured. Okay, then you are doing some 5 times measurement, as I said, 5 times. Okay, 5 times. All right, so each time you are getting one measurement. See, L1, like once you get 2.48 meter. Okay, 48 meter. Sometime you get L2 is equal to, like second time you get this much. Then third time you are getting 2.50 meter. I think for, yes, once it was 49. Okay, 49. So then fourth time you have measured this much, and then fifth time you have got 2.48 again. So like that you have measured. Okay, this is 49. So can you tell me what is the average value? Do you have the calculator with you? If not, I'll tell you. If you just add all of them, see, they will ask you what is true value. True value means mean value of all this measurement. Okay, true value means average value. Okay, average value. So I'll add all of them. Okay, see what we are going to calculate. They will ask you what is the absolute error, what is the true value. Okay, absolute error. We are just calculating what is called absolute error or final absolute error. Okay, final absolute error. This is what we are calculating now. Okay, so you have to find out the mean first. So I'll just add all of them. I'm not writing these values. I'm just telling you the result what we should get, and divide with 5. This will be meter. So you will get actually 2.48 meter. Okay, you'll get 2.48 meter. So what is the true value or mean value? This is the one. Okay, now you have to find out the absolute error and find the result. Write the result. Okay, so okay, then I'll just clean this part, and see, I'll just write my true value somewhere. I know the true value now. Then I have to find out what is called average absolute error. Okay, we had already learned the theory, but now what we are doing, we are just applying that theory to make our understanding little more concrete. So we have got this as, so this is called mean value or average value or true value, this much meter. Okay, true value. So then I have to find out final absolute error. Before that, you have to find out what is absolute error. I hope you remember absolute error. Actually, you will get 5 absolute error. What are those? The true value minus L1. So this is actually the same. You'll get 0. Okay, if you remember that. So again, delta L2, see, true value minus L2. This means, see, you get 2.48 minus 2.46. Okay, so this you will get actually 0.02 meter. Okay, like that you have to find out for all of them. Okay, for all of them you have to find out. If you find out delta L, see, but you have to take the uh, you have to take the magnitude of the all of them. You have to take the magnitude all of them. Whatever you get, you have to take the magnitude. If you get sometime, you will see, you will get -1 or minus, maybe minus 0.1, like that. Still, what you have to do, you have to actually take that -1 as +1. Okay, then only it is in the definition itself we have learned the magnitude of the like difference between true and the individual measurement, that is called absolute error. So you know what we'll get, like we'll get for all of them, and then I'll find final absolute error, which we are going to find now. Final absolute error means this this one. Okay, so I have to take average for all of them, whatever we have got. I have not done the rigorous calculation here, but I'll send you some uh, exercise part, quiz part. If you practice over there, then it will be all right. So see, this is the absolute error. See, I know the value for each of them, each individual absolute error. I know. So that was, so if you just take the mean, you know what we get actually is 0.01 meter. So this is called final absolute or mean absolute error. Okay, or final absolute error. So once I get this, then I have to write the final result of the experiment. So hence, length of the rod, therefore the length of the rod L is equal to, see I have got L average plus or minus this mean absolute error. So that means L average is actually 2.48, and this is plus or minus delta L average, that means this is the value. So you have to write this one. Okay, Deepa, have you got the like concept how to find out absolute error, mean absolute error, and how to report your result, experimental result? You have to report your experimental result like this. Okay,
Yes.
like this.
Okay,
You
yes, sir.
look here. Okay, do you understand this?
Yes, sir.
Okay, I'll anyway. Yeah, anyway, I'll send some um, exercise. Okay, I'll send some exercise for you, quiz. Okay, so you know what does this mean? What does this mean? I'll write once again. What does this mean? This L average plus or minus delta L average. So this means actually the length can vary. Length can vary between two values. One is L average minus this, or less than that. Okay, this is average. It can be greater than L average minus absolute value, or less than this. So the error will be in this range. So length will be in this range. So L will be, the minimum value will be this one for length, and maximum value will be this one. Okay, this is actually maximum value. Okay, in fact it will not be equal, it can be yeah, I think it can be equal also. Yeah, it can be equal. Yes, it can be equal. So this is minimum value and this is maximum value. Okay, understand? So the length will be in between this. So see, my length was 2.48 plus or minus 0.01. That means you know your length can vary. If you just take it, it will be either this much meter, okay, or so it can be this much meter, or it can be uh, if you add this up, this much meter. Okay, your length can vary in this. Okay, and this error is coming actually due to your measuring instrument itself. Okay, measuring instrument itself. All right, so this is how you should report the result. Now see, one more topic we need to learn, that is called percentage error. So sorry, relative error. What is relative error? Relative error. See, we have already learned the absolute mean absolute error. Okay, actually it is defined as the ratio of mean absolute error to the true value of the measurement. Okay, true value of the measurement. Okay, so this is the mean absolute error to the true value. So in the previous example, we have got mean absolute error as 0.01, and what is the true value? 2.48. So if you take the ratio, you'll get some value. It may be some. Uh, it will have some value, and so this is actually called relative error. Relative error. So do you understand what is relative error? It is the ratio of mean absolute error to the true value of the true value of the length. Okay, so this is what is called relative error. Now what is percentage error? Percentage error means, see, percentage error is actually if you just multiply 100 with this relative error. Okay, percentage error means relative error multiplied 100, and then you have to write percentage like this. Okay, this is it. So what is the relative error we have got here? This one. And now if you multiply 100 with this will be giving you percentage error. Okay, this will give you percentage error, and in fact you'll find that the percentage error in this particular measurement will be uh, so 0.01 by 2.48 into 100. So this will give you around 0.04 percentage. Okay, this is called percentage error. So once you know what is absolute error, what is mean absolute error, then you know what is uh, relative error. So relative error is actually the mean absolute error divided by the true value of the measurement. Okay, true value of the quantity, I should say, true value of the quantity. So if you take the ratio of both of them, then you get relative error, and if you multiply 100 with that, then you get percentage error. So these are actually very important. Okay, very important. And any result you will see, experimental result, any quantity will be written anywhere, so there will be plus minus something. Okay, so that will be taken as absolute error. So what I'll do, I'll just send some quiz question for you. You have to solve and send me so that I can correct you if you are doing something wrong. Okay, so we'll just move to the next level of today's teaching. Okay, so next thing what I'm going to teach you today is actually uh, the combination of error. That means, see, I have to write the error, right? Suppose I have a quantity z. Okay, so that quantity is sum of some two quantity a plus b, and in your experiment you are just measuring this value. This is the value you are measuring. Okay, measuring this is as a whole, but in that experimental process you have to measure suppose two quantities a and b, and then you have to sum them up. So in the experiment what actually you are doing, you are measuring a, okay, measuring a in the experiment, and you are measuring B also in the experiment. So once you measure these quantities, so in each measurement there will be some error. That means you have, obviously we know we have to write the error. Suppose A is the, so a final A will be A mean plus or minus delta A mean. Okay, this is how you have to report. Okay, so you have got two quantities now. You have got two quantities. Okay, so what I'll do, I'll just take A itself is the true value. So A will be actually the measured. After measurement, this will be the value. Okay, and with B also you have some error. Okay, now what is the error in? So then when you are writing the result of this experiment, you have to write the this plus minus delta z bar. Okay, that is the absolute value, absolute error, that you have to write, isn't it? So I'm just removing the bar, I'm just writing like this, plus or minus delta z. Okay, so suppose you have to write this delta z, then how do you write? You have two quantities A and B which are summed here. So if you are going to write this z equal to z plus or minus delta z, then look, you have the measurement here and here, they also have error. So finally, you know what you have to write? I have to, just a minute, see, z, suppose it has error delta z plus minus, this is the quantity. So you have actually, you know, you have a, sorry, a bar I am not putting, so I'll just remove the bar. You have a, and along with its error delta plus minus delta a, this is absolute error obviously, and then b, along with that it also has its absolute error. Okay, all right. So now how to write the actual result? So suppose a plus b, you can write, then you have plus minus delta a or plus minus delta b. So how to write this thing? Actually, in the measurement, when you write the experimental result, you have to always write in terms of maximized condition. Maximized condition, okay? In this case, you will not find difficulties. See, this is delta A plus or minus. You have to take always plus here. You should not take minus. So you have to take always plus in between, okay? Because you are doing, so error cannot be minimum, error will be always maximum. Okay, what will be the error? Error will be always maximized. That's why I'll not take any minimum minus sign inside. Okay, I'm not taking minus sign here, you look, even though you have plus or minus, so this will be added. So what is the learning point here or bottom point here? The error of individual quantities will be additive, will be additive. Okay, so what is your error in this quantity then? In the z, delta z, the error will be delta a plus delta b. So the absolute error in each individual quantity will be additive. Okay, they will be just simply summed up. So hence the rule is the maximum possible error of two quantities in the sum of two quantities equal to the sum of the absolute errors in the individual quantities. So I'll just clean everything. I'll write what is see, I had taken a b two quantities. So when you measure both, you will get delta z delta z. So a plus b plus or minus a plus b. See, this will be always positive in between. So delta z, so the error in this quantity, this is delta a, this is delta b. So always has to be written as the sum of the individual, like sum of the errors in the individual quantities. This is the case of summation. Okay. Why is it so? Why you have not taken the minus? We have excluded the minus because error has to be maximized. Always error has to be maximized. Okay. So this is the rule for summation. Now we'll see what happens when we do we take difference or subtraction. Same quantity z. So I'm just subtracting each other or taking difference of a and b. Obviously, so this quantities. So what will be delta z? In this case also, the error will be individual absolute error will be additive. Whether you are doing summation or you are doing sub subtraction or taking difference, okay, your error will be the summation over or the sum of the individual absolute error. Okay. In case of difference also, you look, I'm writing here delta a plus delta b, because to maximize, what it is, to maximize the error. Okay, to maximize the error. And this is the way actually. Okay, so you have understood when you have two quantities in a summation format. So see, in the question there will be given, like, see, there are there is, suppose, a force has been measured. Okay, force is equal to a mass into acceleration. So mass, in the mass measurement, there is some percentage error will be given. Okay, some percentage error will be given or absolute error will be given. So some 0.01 absolute error, and in this 0.05 absolute error in this acceleration. So what is the uh, error in the force? So this is the multiplication case. Okay, we have learned in case of summation or addition, we have to add the errors. Okay, but what happens when I write, suppose, density also, m by v? When I take multiplication or division, how do I write the errors in the final result for a final result of individual quantities? So see, now we'll see the product quantities. When you take product, so how do I write the errors? Okay, in product, same quantity I'm taking. Okay, so this is a and b, this is the product. Okay, for this is scalar quantity, numbers only. Okay, that's why in between, if I don't give any sign also, this is multiplication term. Okay, so suppose the error in z is delta z, so I can write this plus minus delta z. Okay, which I have to find out actually from the individual quantities as absolute error. So in this, you look what I have to write. See, I have a plus or minus delta a. Similarly, I have b plus or minus delta b. Okay, look what I'll do here. I'll just divide this side with z. Z means, you look here, you will be ab here, you'll be having uh, okay, this side here. Okay, all right, I hope it is going okay. So look here, you will get here this plus minus delta z by z. Okay, now if you multiply this you will get ab. Then see, I am just multiplying with this one, then I multiply this and this, so this is plus minus a delta b. Okay, then I'll just multiply this one, so plus minus delta a b. Then I'll multiply this, so this plus minus, all right, delta a delta b. So these are errors. Errors are very very less, you have seen, right? 0.01 etc. Okay, so that's why when you multiply two such quantities it will be even less than this quantity. Okay, that's why this small quantity, this one I can neglect it to be 0, very very small. I'm just neglecting this quantity, so the remaining quantities are this. See, even down there was ab, so I can just do this plus minus, this will be delta b by b, then plus or minus delta a by a. Okay, so I got this. Look, so then see these quantities are identical, so I can write delta z by z as delta b by b plus delta a by a. What are these called? These are called fractional error. So you look, this is called fractional error. Fractional error. Fractional error. Okay, this is called fractional error. All right, this is called fractional error. So what we get, and see here there was plus or minus here, but I am not taking the minus. Why? Because I have to maximize the error. Okay, I'll clean everything and I'll write. So in case of product I have z. Z means a plus b. This quantity when I am doing measurement, so I have to write the error delta z by z. This is called fractional error. This means fractional error in individual quantities, and then you have to sum them up. Okay, you have to sum them up. See, minus I am not taking. Okay, you have to sum them up, you have to add them, because you have to do the maximum proportional or permissible error. This is called maximum. You have to always maximize the error. That's why you have to take the positive in this case also. But in case of summation, see, when we just added these two quantities, then what we had done, we had just taken the sum of these. Like, say, I'll tell you what we had. In case of sum, we have just delta a plus delta b. But in this you look, you have to get the fractional error. Okay, so in this case you are getting the fractional error. These are called fractions, right? So these are fractions, so you have to find fractional error, and in that case you have to add, if even if there is some negative quantities, but you have to take positive to make the error maximized. That is the actual like actual way. So the maximum fractional error in the product, this is called maximum fractional error in the product, will be product of two quantities will be always equal to the sum of the fractional errors in the individual quantities, which I have written here. Okay, I hope it is okay for you. So now what I'll do, I'll just go to the division part. Okay, when I have to do division, so in case of division what we have to do, suppose z is equal to a by b, and in this case also there is some error. Okay, delta a, here also some error is there, delta b, and suppose in z it is delta z. Okay, z plus delta plus or minus delta z. Okay, so I'll write here again plus or minus delta z. So you have a plus or minus delta a, then b plus or minus delta b, these quantities. Okay, now look, what you can do is actually uh, just uh, a plus or minus delta a, this I can just think, I'll just take up delta b with a minus here. Okay, then I'll just do little bit of simplification. Suppose I'll just take uh, I'll just take a common in this case and b common in this case. So 1 plus delta plus or minus delta a by a. Okay, and look, multiplied by, so b inverse and 1 plus delta b by b, and this is also minus inverse. And okay, since I have small space here, I'll just use this part also. So if you have a 1 plus x whole to the power n, where your x is much less than 1, you might have already learned in case of power series expansion, you can write 1 plus nx up to first approximation. So that like that quantities goes, since this is a very small, further you will get actually x square with some like some associate, then plus some associate with x cube, like that it will come. So since small, like x is already smaller than 1, I'm just ignoring this um, x square x cube term. Okay, you might be thinking where I'm getting like this thing that I have to introduce here. Actually look, I have a quantity now, 1 plus delta b by b whole to the power minus 1. So I'll be using this formula to simplify this one little bit. This is plus minus. So I can write here plus or minus, see, minus of 1 into delta b by b. So which I can write again. So this is the approximation I have used here. Okay. See, I have used, so I'll get minus or plus delta b by b. And see, I had this one as well. Okay, this one. So as a whole, what we get, just a minute. I'll just clean this thing. I had, see, this line I'll keep because I know what I have here. So you have z plus delta plus or minus delta z. You have, this is a into 1 plus or minus delta a by a, and into, this is 1 by b, b inverse means, and this I have already approximated, this is to be minus. So this is actually I'm writing minus or plus delta b by b. Okay, all right. So look, what I get actually, this I'll write here, the a by b, and then I can multiply, this is 1 plus minus. So this plus minus or minus plus, actually you'll get minus plus only. So minus plus delta b by b, and then again you will get this, if you multiply plus or minus delta a by a, and the multiplication term here, delta a by a into, this is plus or minus, into delta b by b. So these terms actually very small, so I'll just cancel this out to 0. Then you get, see, what you get is actually a by b, then 1 plus or minus, you have to take plus or minus common, then you get delta A by A plus, actually here you have to take only plus delta B by B. That means in this case also, as you have seen in case of um, addition and subtraction, both cases we have taken positive of the absolute errors, like summation, addition of the absolute error. In this case also, finally what you have to write, in the case of division also, you have to take the summation over, or the addition of the individual fractional error. You have to write individual fractional error. Okay, so you will get here, see, you don't have to do this much calculation in when I'll give the exercise for you. So see, delta z by z will be actually simply this one, delta a by a plus delta b by b. Okay, this is the error in this case also. So summation over the fractional errors. Okay, nothing much. So in this case also we had got the same thing, delta z is equal to, in case of multiplication also we had got the same thing. Okay, what we got, delta a by a plus delta b by b. This is how we got in case of product or multiplication, and this is actually for division, both are same. Okay, now we'll just go to another part, that is the power part. Suppose I have z is equal to a to the power n. So in this case, look, I have, suppose I have error in this a plus delta plus or minus delta a, then whole to the power n. So how do you get this? So in this case also, what we will do, a to the power n. So a I'm just taking common. So suppose my error is in z is plus or minus delta z. Okay. Okay. So you will get here delta a by a whole to the power n. If I just make the same approximation which I have told already, where x is much less than 1, you can write 1 plus nx. So same thing I'm going to do here. Look here. Okay, so this is a to the power n, and then it is plus or minus n into delta a by a. Look, okay, so if I just divide with z, then if I divide with z plus or minus delta z by z, then see, z means a to the power n. So a to the power n here goes off, and here also you get 1 plus or minus 1 plus or minus delta z by z. Okay, this is equal to 1 plus or minus n delta a by a. Okay, look, this thing, I'll just clean this portion. So my quantity was z. Look what we have got here. If I just compare from both sides, delta z by z is equal to n times. I have to take plus in to maximize this error. So then n times of the fractional error. So in case of power, what you have to take, that power will come in front, and you have to take the fractional error for the quantity. Okay, so in case of power, what is the maximum proportional error? The fractional error in the nth power of a quantity is n times the fractional error in that quantity. Okay, so this is all. Okay, so the combination of errors we have learned. So in case of summation, you have to take the summation of the absolute error. In case of um, subtraction, you have to take the addition of the errors. Okay, addition of the errors, not the minus in between. You have to take always positive. Why? To maximize the error. Then we have learned what we have got for multiplication, the sum of the fractional error, sum of the fractional errors. And in case of division also we have seen the sum of the fractional errors. Okay. And in case of power also we have got, and what is that? Whatever power you have in your uh, quantities, so that power will be coming in front. So if it is n power of this a, then you have to write n times the fractional error in the quantity. Okay. So I hope you have understood all those things. Anyway, by evening, sorry, by night I'll be sending one uh, sheet, like quiz sheet, okay, on this particular topic, error and all. Okay, so you have to solve them. The questions will be actually of like maybe some will be cbse, and some maximum will be of competitive exam type. So there will be multiple choices also. You have to solve them with the knowledge you have got today. And then uh, next day we'll be learning uh, dimension analysis. Okay, what is dimension analysis, what is dimension, what is dimensional analysis, etc. will learn. And few more things in this error also are there. uh, so those things also will learn in the next class. Okay. So
Okay.
Deepa, I'll be yes, okay, I'll just stop the class here. See you, I think on Thursday we'll have the class again. So we'll be uh, discussing the rest of the chapter, dimension analysis. Before that, some things are there in errors still, so those things also we'll be discussing on that class. Okay. All right, bye bye, see you on Thursday.
Okay.